California is arguably the best place to see your favorite live acts, but sometimes it's the venues that host them that are the true rock stars. Take the Greek Theater, for example. This 5,900-seat amphitheater is located in Griffith Park in LA. It's been named the best small outdoor venue in North America multiple times and has hosted world-renowned acts such as Neil Diamond, Florence and the Machine, Radiohead, and Adele. Fun fact, it was also featured in the 2010 film Get 'Em to the Greek. The Hollywood Palladium has been a staple in the city since the 1940s. Everyone from Stevie Wonder and the Ramones to Jay-Z and the Black Keys have all played the Palladium.
Okay, I know what you're all thinking. Wasn't this supposed to be a video about a math unit? What does this have to do with math? Math is not just numbers and calculations. Math is everywhere and in everything. It's in the patterns of nature, in the proportions of the human body, the logic behind games, and it's definitely in music and in architecture.
74 feet above the stage, yet I could hear the sound of a pin drop or a match strike. The discovery of how sound waves travel influenced the design of the theatre. And this is how it works. Built into the slope of a hill, 55 rows of steeply banked benches are arranged in a perfect semicircle, 177 feet across. Because sound waves travel in a circular motion like ripples in water, they radiate symmetrically out from the stage. The initial waves enhance later ones as they reverberate off the stone structure. This exceptional capacity for sound reinforcement accounts for the theatre's superior acoustics.
My unit plan is all about conic sections, but the students aren't just going to learn how to graph them and solve equations. We're going to do activities that engage and excite them. By the end of the unit, students will actually get to design and create their own entertainment venue, incorporating the acoustic properties of conic sections into their building design. My goal is to make connections between what is learned in school and the world outside the classroom, which not only means bringing in authentic assessments and assignments, but also incorporating technology to keep up with our ever-advancing world, a goal that works in concert with the new Common Core State standards. Speaking of standards, this 4-week unit will address a well-rounded range of standards meant for a class of high school students taking an Algebra 2 course. The standards include Common Core State standards in mathematics and in language arts, as well as ISTE's technology standards. By the end of the unit, students will be able to describe a conic section as the intersection of a plane and a cone, analyze and derive equations for each conic section given their geometric descriptions or general form, determine if a given equation in general form is a circle, parabola, ellipse, or hyperbola using the method of completing the square, relate simple parameter changes in the equation to corresponding changes in the graph, apply information about conic sections to design a new stadium or theater that enhances sound for the audience, and present and defend their design using a business proposal that includes a written letter, physical model, and digital presentation. But teaching math and connecting its concepts to applicable real-world projects was not my only goal. I also wanted to make sure that my unit plan addressed the individual needs of my diverse learners by using technology to target the 8 multiple intelligences as defined by Howard Gardner. For example, throughout the unit, students will keep daily blogs on blogger.com in which they will use a variety of written entries, podcasts, and video recordings to journal about each day's lesson. They will even post a video blog entry recording themselves as they cut apart an actual styrofoam cone to illustrate each conic section. This activity addresses the multiple intelligences of students who are verbal, visual, kinesthetic, and intrapersonal. Rather than traditional direct instruction, many of the lessons in the unit involve students discovering mathematical properties on their own. With the use of the iPad app MathGraph, students can explore the graphs and equations of all 4 conic sections by manually altering variables and parameters. Then, using apps such as Sketch and Inspiration Maps Lite, students are able to create notes and graphic organizers. This activity focuses on the kinesthetic, logical, visual, and naturalist intelligences. Another lesson in the unit plan will have students visiting an outdoor amphitheater such as the Hollywood Bowl, where students will explore how sound, architecture, and conic sections are all related. In small groups, they will listen to music being played and assess where the focus is located in the amphitheater using a combination of mathematics and listening skills. Afterward, they will use mobile devices to pin that location using Google Earth and tweak their work to one another. Here, musical, logical, naturalist, interpersonal, and visual intelligences are being targeted. Those were just a couple examples of the activities and technologies used in the unit plan and the multiple intelligences that they targeted. Some of the other technologies included are shown here. The technologies listed are an integral part of my teaching. However, they were selected because they fit my goal of teaching the content in ways that enhances learning and addresses all my learners' needs and multiple intelligence strengths. Students come first. The technology is only a tool to help make learning more effective and efficient.